After the success of printing carbon fiber reinforced PA12 material, it's time to check the material properties for application. Hi, welcome to Slow Engineering. I'm David. The carbon fiber reinforced PA12 is filled with carbon fiber to enhance its rigidity, toughness, strength, and improve printing difficulty. But how exactly does the material perform as frame parts on a machine? Let's find out. Machine frame structures needs to be rigid on most CNC machines. They usually use cast iron to make a heavy and sturdy base and frame to make sure all axes are vertical and without any relative movements when operating. If you want to use this material on machine's parts, the first thing is make sure the material performs well enough. The test on rigidity, stiffness, is flexural modulus, or called bending modulus. The testing can also be found in the ASTM D790 or ISO 178 standard, using two side supports and applying force on the center to measure the deflection of the bending material. Use the formula to obtain the flexural modulus. The higher values of flexural modulus means the material is more rigid. I printed some specimens followed by ISO 178 size, 4mm high, 10mm wide, and 80mm long. The two-side support has a distance of 64mm. All 3 points are filled with 5mm rods in diameter. I prepared 6 bottles of water. Each of them measure in 500 grams. In the following test, all specimens will be loaded from 500 grams to 3000 grams. Last time I showed the carbon fiber reinforced PA12 has different properties on absorbing moisture. So, I prepared 2 different sets of this material. One is soaking into water before testing for 24 hours, and the other set is staying in the drying oven with 80 degrees Celsius for at least 10 hours to fully dry. I also get some reference group like 2 different sets of PLA, a set of PETG, and a set of ABS. All the specimens are printed with 0.2mm layer height, 3 bottom layers, 4 top layers, 3 walls, and 100% infill with light patterns in Cura. All of them are also measured the displacements on various loads. Here is the diagram showing all the materials I test from 500 grams to 3 kilograms. We can see the white PLA has the least displacements when loading. The second one is fully dry carbon fiber reinforced PA12. And the third one is another PLA in red. Surprisingly, the last one is also the carbon fiber reinforced PA12, which soak in water before testing. It means this material has different performance depending on the moisture it absorbs. So this material might not be suitable for being CNC frame parts. The PLA seems more stiffer than other materials too. That is why most projects on CNC machines are using PLA as frame structures. Another noticeable difference is the PA12 with carbon fiber performs continuously deformations when loading. Not like other materials will stop deforming after a short time. So the value I got will not represent certain values for PA12CF. Ideally, they should perform a straight line with a certain slope value like others. It is a great test to test whether carbon fiber reinforced PA12 is suitable for some applications that need to perform stiffness. Obviously, this material is way more suitable for some applications for unbreakable purpose, and PLA seems to be more reasonable to use on frames. What do you think about using 3D printing parts as frame structures? Or I just stick with all metal solutions on CNC machines? Leave your source and reasons below. Now I tend to use 3D printing in various applications. Like, share these videos and subscribe to this channel if you learn something. Or consider becoming a Patreon supporter to unlock more contents and support my projects. Thank you for watching. See you next time.